Today I am going to explain about design of slab formwork. So here first we have to know what and all material is used for slab formwork. The major material are used for slab formwork is plywood, timber, okay, that is a timber, wood, doka, wooden, H-beam, I-beam, that is all are same only. Then vertical props. Some general details for all those things like a plywood, timber and props. What are the general details is length, width, thickness. Okay. Then bending moment, shear force as per certificate, testing certificate, test report or else manufacturer test report. So now that is for the plywood and this is for the timber beam detail. This is the depth of, we can say like a H doka, I doka or H beam, I beam. Okay, this is the 200 mm depth and 80 mm width, that can be vary according to the requirements. This is the bending moment and shear force of this material. Now I want to show you some pictorial view. This is a slab formwork top view. This is plywood, okay, and below the ply we have kept support. This is primary beam. This red color is showing this is a primary beam, and this is the secondary beam, this green color, and here this is a black spot. These all are the props, vertical props, which we have kept at some distance, some spacings. So what we have to calculate means we have to calculate a spacing between the primary beam and a spacing between the secondary beam as per the specifications, loads and requirements. Let us consider thickness of slab is 300 mm. Okay, now let's calculate load. So calculation of load right now. Dead load 0.3 into 25 plus 1. This 0.3 is 300 mm thickness, which we have considered before. We have converted into millimeter to meter. That's why we have written here 0.3 into 25 plus 1. 25 kilonewton per meter cube is RCC density. Okay. And next 1 kilonewton per meter cube is safety purpose. We have kept extra. Or otherwise we can consider as a wind load 1 kilonewton per meter cube. So total is 7.8 kilonewton per meter square. Next, live load. Live load is, we have considered taking 20% of dead load as a live load. So dead load is how much total? 7.8 kilonewton per meter square. 7.8 into 20%. 20 divided by 100. So we got 1.56 kilonewton per meter square. As per IS code, it should be 0.9 kilonewton per meter square. But yet, we have considered 1.56 kilonewton per meter square for safety purpose. Now, going to calculate formwork load. So let's consider formwork load is equal to 0.5 kilonewton per meter square. But this we can calculate by taking load of plywood and all the timbers physically also. So currently now we have assumed 0.5 kilonewton per meter square. Next, total load equal to dead load plus live load plus formwork load. So now total load will become 9.86 kilonewton per meter square. Step 1 we have done, that is load calculation. Now step 2 is design of plywood. So here design of plywood, we have considered that plywood 18 mm thickness, and for that what we have to do right now, we have to find bending moment, sorry, already bending moment they have given, shear force also they have given, just we have to find length for spacing. Okay, here this is the formula, bending moment is equal to W into L squared divided by 10. W is the load. Okay, and this is the already they have given 0.34 kilonewton per meter, sorry, kilonewton into meter they have already given in the question itself. So right now just we have cross this, L square is equal to 0.34 into 10 divided by W. So we have got this 587 mm, 0.587 meter converted into millimeter by multiplication of 1000. Okay, now check for shear force. This is the formula 5 divided by 8 into WL, and shear force already they have given 5.54. See, bending moment 0.34 and shear force 5.54. Now just we'll cross this and we have to find length for spacings. So length equal to 8 into 54. 8 into 54, just you do cross multiplication. Okay, so this will go that side and this will go that side. So 8 into 5.54 divided by 5 into W equal to L. So we have just multiplied and divided. Now we have got 0.898 meter converted into millimeter, and we have got length is equal to 898 millimeter. Now we are going to check for deflection. Checking for deflection. Deflection equal to 1 divided by 145 W L power 4 divided by E into I equal to L divided by 360. That is the formula. Consider as equation 3. Okay, we have just put the value 1 divided by 145, W that is a load 9.86 total load, L power 4 divided by E into I, this is the constant value, we have kept as 2.7, that is a constant value. Okay, equal to L divided by 360. So just we cut this L, keep it at 3, that is a 4, 1 it is deducted. Now L cube equal to 145 into 2.7 divided by 9.86, just have calculated. If you remove this cube, means in the square root that 3 will be here in cube. So after calculating this, L equal to 0.48 meter, that we have converted into millimeter, so that is a 480 mm. Okay, now comparing that equation 1, 2 and 3, here after comparing, the spacing of secondary beam is to be considered as lesser value, that is 480 mm, just now we have calculated. Okay, what and all that equation we are comparing, this is the equation 3, this check for the bending moment, this is equation 1, and check for the shear force, this is equation 2, this value. Okay, so now secondary beam is to be considered as lesser value, is that is 480 mm, just now we have calculated this is the lesser value out of the 3 equation. Now 450 mm is near to 480 mm, right? This we have considered 450 mm. So now considered spacing is 450 mm, and this I have written the side like a less spacing gives more stability, that's why we have kept 450 mm. Now this is a step 3, design of secondary beam. Okay, this is the beam, this is the plywood, secondary beam. Secondary beam means this, in this way. Now we are going to design of this, what could be the spacing according to the load calculus. Okay, so here effective length is 450 mm from here to here, center to center, 450 mm plus 40 plus 40, this is the width of this 40 mm here and 40 mm here this side. These are the effective length where the load will be applied. 40 plus 40 minus 18 mm thickness of plywood. So right now we got, after calculation, 512 mm. We have considered as a 500 mm. Next, new load will be applied on secondary beam is 9.86 into 500 mm, that is converted into meter. So that is in previous load 9.86, and the load will be applied, that is effective load, which will be only for 500 mm. So 9.86 into 0.5 meter, which is 4.93 kilonewton per meter. Okay. Next, checking for bending moment. This is for moment for timber is 5, and now we have calculated according to the formula, and that is a L square, WL square divided by 8 equal to 5. Now we have find L square equal to 8 into 5 divided by 4.93. Hence now L equal to 2.848 meter we have found after the calculation. Next, checking for shear force, already they have given 11 kilonewton. Okay, now that formula is WL divided by 2 equal to 11, just doing the cross multiplication, and L equal to 11 into 2 divided by 12. Okay, so L equal to 4.46 meter. Equation 2 we have just assumed. Now checking for the deflection formula is 5 divided by 384 into WL power 4 divided by E into I equal to L divided by 360. Now just we have put the value W equal to 4.93 kilonewton. Just we have calculated that new load, that is a new load, L power 4 6 360. Okay, so this L, 1L we can cut this. When we will do the cross multiplication, it will come down. That's why we are cutting this, and this L power 4 will become L power 3. Just we have cross multiplied and kept aside. Now when you will remove this cube, it will be a square root power 3 here. Now we have calculated, and L we have found 1.41 meter. Now comparing equation 1, 2 and 3, and then taking lesser value here. From equation 1 we have got 2.848 meter, equation 2 4.46 meter, equation 3 1.41 meter. Just now we have calculated this. Hence taking lesser value 1.41 meter. This is almost equal to 1.4 meter. As much if we are taking lesser value, that will give more stability. That's why we are taking 1.40. It means we are taking lesser value. Coming to fourth step, that is design of primary beam. Okay, that is beam is made of wooden beam, timbers only. So for timber beam, again we have to find new load. Okay, after finding the secondary beams, so new load is equal to previous load applied for secondary beam into lesser spacing. Just now we have assumed, we have calculated. So here new load equal to 4.93 into 1.4 meter. So equal to 6.90 kilonewton per meter square. This is a load, new load for primary beam. Same as previous, we are finding the bending moment, shear force and deflections. Checking for bending moment, this is the formula we have applied. Here everything will be same, just like a previous only. Just we have to put load value different. Just now we have calculated here. So 6.90 same, L equal to 2.4 meter here. Check for shear WL divided by 2 equal to shear value we have assume how much, 11 kilonewton. Okay, so same we have put the value, load is 6.90 and L equal to 3.18. just assume as equation 2. This is equation 1, 2.4 meter, 3.18 meter 2. Checking for the deflection, formula is same, just W value is different. and this L value equal to 1.3 meter. Comparing of equation 1, 2 and 3, we are taking the lesser value we have calculated. Hence, what is the lesser value? 1.3 meters. Okay. Hence, we have taken the lesser value 1.3, which is same like a probe spacings. Probe spacing will be always supported for primary beam only. Hence, the probe spacing will be 1.3 meter. That is a maximum. We cannot exceed more than this spacing. Now, influence area on probes P equal to spacing value of secondary beam into primary spacing beam. 1.4 meter that we have calculated for secondary beam, and for primary beam we have calculated 1.3 meter. Now, this will be divided into two parts. So, 700 plus 700, 650 plus 650. This into this, if you calculate, will get 1.82 meter square. As per our as per our load calculation, total load, how much we have calculated? 9.86. This live load, formwork load and dead load, all those three if you will add will get 9.86. Hence, load on probes is 9.86 into 1.82. This area will be influenced, that load will be influenced on these probes in that area. That is this much, 1.82 meter square. And this is the, hence total load on probes is 18 kilonewton. As per our design and calculation, we have found the value for the secondary beam. This is a secondary beam. From here to here, we are getting total 1400 mm spacing, 1.4 meter, where we are dividing into two parts, 700 mm, 700 mm. Similarly, for the primary beam, we have found 1.3 meter. From here to here, 1.3 meter. From here to here, 1.3 meter. So, and the probes, this is the probes, this black color spot, these are the vertical probes. This is the maximum spacing would be 1.3 meter, where mostly in the construction site people are using here 1.2 meter maximum spacing for the slab. Okay, thank you.